Andrew Musselman, Analytics to Go, is going to present the impossible. He's going to try and tell us how to put together sane architecture.
In theory.
In theory, to get it off the madness every day. So everyone please give a warm welcome to Andrew. Can you hear me okay? Can you hear me okay?
All right, well, thanks for coming out. Can you see that? It's not the movie? Okay. Yeah, so we're going to talk about maintainable machine learning products. Here's my contact info if you want to get in touch. I came from Seattle last night, so I'm not on the same time zone, but I hopefully had enough time to wake up today. Show of hands, who does machine learning development or data science development out there? I know a lot of you do. Okay. So there's a lot of tools. The last 5 to 10 years have seen just an explosion of tool building, platform building, things to enable your teams. And this is just a laundry list that I picked out of a hat, in 30 seconds of just machine learning tools. And then you can get into vendor solutions. You can get into, which tend to be kitchen sink things like end-to-end. We can do everything you need, whether it's a fully featured machine learning application, or whether it's letting your data scientists get down and write SQL queries or write code, or the answer is automatic solutions. We will data robot, for instance, will get in. You can upload your data and then figure out what KPIs you should be looking at. So that's a lot of things to take in. A lot of teams have different preferences. Everybody comes with their own preferences. So the challenge for a lot of machine learning teams is how do you choose the right tools? How do you get everybody up to speed? How do you make everybody happy in their job and productive as a secondary, hopefully. But that's just machine learning pieces, because to build machine learning products, you need a lot more to be able to bring your data in. You need to be able to do feature extraction, feature engineering. You need to plot some results. While you're doing your work, you need to see how you're doing. You need to present your results to your stakeholders, to your customers. You need to have some kind of place to deploy your results, whether it's a report that gets emailed out, whether it's a website, whether it is a dashboard that's online. And then along with that as well, there are other pieces that can inform what you're doing as a machine learning practitioner. You could have a search index that you use at the back end for your machine learning methods. You're going to need to be able to manage your models. You're going to need to look at degradation of performance over time. You're going to need to keep track of your data versioning, so that you have, as you're doing your work, you don't have 50 different versions of the same script with different parameters, and you've lost track of which data came from which ETL tool. And then you will also need monitoring for your application. You need to keep track of how well it's performing, whether it's under load from customer behavior, or whether it's the model degrading over time. So that's a lot of moving parts. I'll do this. Right? So we just want to be able to predict. You want to be able to, given an input, predict an answer. And I'm not downplaying linear regression or logistic regression, because really, if you're doing one of those at scale in production, you're ahead of most people. And a lot of times that's the right answer. That's the right thing to be doing. And for the sake of this talk, if you're getting a linear regression at scale in production, that's prima. So just about me and why I'm here. Well, first of all, Trevor is on the GMC of Apache Mahout. I'm the chair, and so I want to see him. This is how we see each other when we work on these projects together. I've held positions as Chief Data Scientist for Accenture, as Senior Director of Advisory Services for LucidWorks, and now I'm Chief Analytics Officer for a startup called Analytics to Go. With Apache, I started by fixing a bug in Mahout that I use on a customer project. Found the bug, helped fix it, helped with the release, became a committer, EMC member, and now chair. I also do believe in bringing people up into open source internally in companies. So I started a program at Accenture when I was there, where we built little podlings for each project, help people get involved. It's sort of a nice way to organize contributions. Actually sounds a lot better in theory than it is in practice, because almost nobody has the time or inclination to donate the time to open source. So it's something to work on. For fun, I have a podcast, Adversarial Learning. We talk about data science, but mainly we just go off the rails and talk about whatever the guest wants to talk about. I do a lot of outdoor stuff, a lot of indoor stuff, so if you are an amateur radio operator, get in touch. We try to long distance. Another reason I'm here is to talk about the bad things I've seen. Because people do really bad things with good tools. They do bad things with bad tools. So I could tell the story of the first data science project I built, which was a recommender for Rhapsody streaming music. There are a lot of steps that are required to do a project. First, you have to get your data. There's already impediments in place. You have to get approvals. You have to get a whole extract. Somebody has to spend time on it. Once you actually get an extract, then you have to do some cleaning, transforming. You have to figure out what's wrong with this data. Why do I have to look at this? Why can't I join this table with that table? Oh, well, that's because we truncated, blah, 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 blah. On and on and on. Then you get to the fun part that is why we all got into this field to begin with, which is writing 3 lines of code from a line, split, train, and then test an algorithm that's pre-built, look at your results, improve them, and then finally try to publish them, which is another impediment that most people incur when they are trying to do this stuff inside an organization. You may have a beautiful model, and your organization does not know or care or want to put it in production. They don't know how, they don't know where to put it. It may be a simple SQL query in the table that they have operationally up, and nobody will want to build that web call that can make that. So the lesson here is that there is no assembly line the first few times you do something like this. It's up to you as you do it, and as your organization does this, to learn from your mistakes and to make things easier for the people to follow you. So that sounds like a lot of work, it sounds like a lot of impediments, and it's actually not even the whole half of it, because before you even get to what you think of as building a machine learning product, there's a lot of bosses that you have to beat. Because first you have to have an idea, it has to be good, has to have a design that you have sat down and thought through. You have to build a prototype, you have to convince your team it's a good idea for you to spend your time on the clock building it, or even the time that you spend in the evenings, that it's a good idea for them to do it for real. You need to get budget, you need to get priorities. Then you can do all that fun stuff. It's still very hard, has a lot of problems. I personally have gone through situations where I pitched the same machine learning project to 3 CEOs in a row. One who approved it, another who came in to replace him, and then another one who came back, and this project had to get approved again. So this can be a long, long process, and if you're winging it or doing it on your own or scumworksing this or trying to bootstrap this, you're going to have to deal with this. You're going to have to learn how to make it seem reasonable, make it seem good, and make it seem like a good thing for the company. Lots of things die at every stage. So all the stages, if you have a great idea, and it could be even a new company, the company that you're at may not support it, and it may die at any place. It might be a bad idea. It might not work. Your team might not be convinced, you might not get budget, you might lose the priority battle, right? So what's more important for this company is maintaining our product. We cannot afford to take time off of our day jobs to support this thing. Your business priorities might change, and then you just totally take what you get. But what's really poignant to me is when I see projects like this get to the end stage where somebody has birthed a beautiful new thing and they believe in it, they see the value, everyone around them sees the value, but there's no way to put it in production. There's no support for it, there's no, it has not been thought through. So all of these things are a good thing to be thinking about as you build something. So as you start to build, or even before you start to build something, start to think about how you're going to socialize it, how you're going to get buy-in from the company around you, and make sure that when you're building something like this, not only is there a thought of how to deploy it, but of how to measure its success. Especially as far as dollars. So if you can build in a way to measure the monetary value of the thing that you're building, that's bonus, that's a plus. That's the thing that you can go in and say, no, we did an A/B test against this thing, we had the host monitor, we showed that, for instance, our recommender resulted in 50% more cart ads or 30% more checkouts. If you can tie that stuff in together and make it a part of the whole process, you're going to have a lot better time having support. And yeah, that is the single worst way for customers to fail, in my opinion, because if you spent all that time, it's a shame. So let's try to keep these things in mind. And even though there are all these troubles, and practitioners know that these troubles and they're aware of them, it's a high priority for a lot of companies now to put machine learning and AI on the roadmap. You will probably hear these things from your leadership, that you need an ML story, you are behind, you have competitors in the market who are beating you and eating your lunch because they have an ML story. It can be part of reality, and it can also be part of just your marketing and your sales pitch, right? So a lot of companies will simply have to have that on the materials that they go to show customers, just to have table stakes to stay in the room. If they don't have ML, the word machine learning in their deck, that's a black mark against them. In their view, it can be part of the reality too. Then, so you have a few levels of sort of, it's not a bad idea, it's not bad judgment necessarily, but it's a reason why things can fail later. If you have a very high remit from your leadership to do ML at a generic level, that's a super bad warning sign. It could be a very bad problem, because what you might have is a lot of funding behind no direction and no good ideas. That can be very risky. It can also be a good place for opportunity. So it's a good reason to put stuff in production, just to stay current and relevant. But there's a risk involved. Another level where people can get sort of down the wrong path is when they've heard enough. The phrase "knowing enough to be dangerous." They've heard enough about machine learning and AI and they've latched onto one concept they think that they need to do. They might try to apply sentiment analysis to things that don't have any sentiment, like medical records. I've seen it. They might want to figure out what people are saying about them on all of social media. It's a solved problem, vendors do it, and also it's too much work. They might try to figure out how to predict the stock market from sentiment. Again, sentiment analysis in itself is a good thing that should be applied in the right way, but if people are going about things just to fulfill and tick boxes, it can be a risk. And then at a sort of on the ground level, you also have the risks of people having incorrect assumptions about what machine learning can and can't do. A lot of people do believe, and I have heard things like this, that machine learning can accept the data that you give it, and then machine learning can then answer you what your KPIs should be. So what you should be measuring. That's pretty aspirational. I think that's a pretty big reach in a lot of cases. And then you have the belief that machine learning is a commodity now. I think it's more commoditized, and there's libraries that go off the shelf, but a lot of these things get very messy when you do them at scale, when you do them with a team, when you do them with people who don't have the same workflow, that don't have the same sort of team culture as far as how these things get built. So as a result, a lot of companies who are trying to do this stuff are in a very, very bad spot, which is an urgent need that's ill-defined and very, very big. So it's not a great place to be necessarily overall, but there are good opportunities in there. You can manage your way out of that, and you can actually make some good stuff. What people often do to combat that urgency and sort of manage the scope is do one or a combination of a few of these things. People are often inclined to hire consultants. Sometimes that's a good thing. There are good things about consultants. Sometimes you can take what can be sort of a standoff situation where you can't, nobody's going to give an inch, and you can sort of get on a sidetrack and get things moving in a green field, start over with a prototype, and then sort of merge that in. That can be good. It can also be terrible. Another way people try to do this is to build it all themselves, because They know their domain problem, they know their tech stack, they know, the kinds of things that they want to do. They think that changing direction in that is too risky. So that's actually a good point in some cases, right? Then some people will just buy a fully fledged vendor solution. Often, in my experience, they will get into a situation where they do need to pay for a pro serve to get themselves out of that, to finish the project. And then last, my favorite is to, non-ironically, is to research and benchmark off-the-shelf open source stuff, see how you can fit it together, see what's going to work for you. So I am biased toward open source as far as a way to build things, but these are several sometimes correct ways to do these things. And it's not like I said, it's not the tools that make things dumb. Sometimes it is a good idea to get off the vendor and move on to something else. This is the situation I did see at a customer one time. We're going to get off Teradata. We're going to dump all the tables out of Teradata into HDFS. You save a lot of money, but wait. So they just took unlimited files with no information at all. So not every migration out of Teradata has been that way, but you do have to pay attention to what you're doing, and I'm sure it's pretty required. But another way we can lag ourselves is getting off the legacy code that we've all built, we all know and love. I worked at a company that had a web development framework that somebody in the company had written in a 2-week period on his own before spring. And it was great. You could use JSP, you could get all sorts of custom tags. It was wonderful. And you could get your web developers XML config to work with. They didn't have to do Java, they didn't have to compile things. But on the other hand, there was no way to search any stack traces outside the company. There was no way to figure out anything that we may be accustomed to now with Stack Overflow or Google. All that stuff was completely locked inside. There was one configuration file for one web page that was 9,000 lines a month, and it was horrible. But here's, moving off of your own stuff to a vendor sounds great, because vendors always tell you things, and it's going to take a month. It sounds good, because it's going to be painful. It's going to take us a month. It's going to set us back, but it's going to take less than a month. But then you talk to your IT team, and they say, it's actually, you can't do it this year. We just don't have room. And that stuff happens, like non-stop. Anytime you try to do anything, you can have just steel barriers thrown up in front of you without expecting it. If you don't expect it, you're gonna have a problem. But here's where we really achieve enlightenment. The vendor can't provide the connectors we need because they don't support SharePoint and they don't support Confluence, they don't support GitHub. So, but our intern says they can do it, and we're all gonna have a happy ending here. So just a little comedy just to get you keyed into what I'm talking about here, which is people choose tools on a one-dimensional spectrum usually. I think it's because they're running away from their current horrible situation toward what they think is going to be a good future. But it's not a one-dimensional choice to do any of this stuff. If you want to choose between a pure vendor solution and legacy non-vendor stuff and open source stuff, you really need to think about it in terms of a very complicated balance. It's not just this or that, it's how these things work in concert together. And we've all seen these trade-offs. It'll cost you more and have less control. The promise is quick solutions that someone else will have to handle. There are pluses and minuses to sticking with your legacy stuff because you do keep that tribal knowledge internally. The drawback is that tribal knowledge does not scale. You can't hire for that stuff. You need to learn on the job. With open source stuff, you can configure and extend your own fork of this stuff, and you do have pretty good options as far as the hiring tools. So, here's an example of how not to choose tools. Anybody who's a veteran of data science and machine learning knows that this is many things at one time. It looks horrible. It's a bad thing. terrible to maintain. You have two people using Python notebooks, different kinds. You have somebody using the Python retrieval, running scripts. You have all your stuff in AWS, great. You have data connectors between, from your development environments up to your infrastructure. And you then have somebody, Jeff over here has written a script to automatically pull down weather data from an external API. Great, thank you. Repeating this and teaching new people how to do it is not something that is going to be enforced very well. And then you have somebody here, using Apache who their work never gets into production, never actually gets involved in what we're doing. Now it looks bad, but in some cases this is a great solution. This will serve you well. It's wonderful. You do need to be able to balance out what you need to do, because you're always going to be able to have bash control available. You're always going to have these connections. If this, for instance, were a very small prototype, it's maybe just awesome, maybe perfect, just to prove out the value. But going forward, you want to have something that's a little more repeatable. So this is a conceptual view of what we're talking about. You can separate these things out, and you can sort of compartmentalize what kinds of skills you need to develop, or need to hire for each piece of the work. On the right, you would have UX and UI. You could have web developers. Anybody who can build a React app, you can hire, bring them on, build it out. Your data scientists can use R, Python, or Spark, or whatever they want to use. Your data engineers can use whatever they want to use. And then you have people sourcing data, bringing it in. Now, this doesn't work without some kind of enforcement to keep people from doing the right thing, or keep people doing the right thing. What needs to happen in here is that each stage has APIs to access each other. So what the company I'm at and what I've done before have built is a way to enforce the right practices between each stage. So when somebody's sourcing data, they have a way to call the data engineering API. Reverse. The data engineering people have a way to call the data that's downloaded and to access it through a common understanding. When they are done with their engineering, they have an API to write to. The data scientists have a similar API that they can call back to get their stuff. When they publish results, it needs to be something that is in a common format for the front end. These things don't just happen, they need to be trained, they need to be decided on. But to get things started, before we invest in big, huge projects and either waste a lot of money or quit our jobs because they're terrible, what we want to do is to figure out a way to encourage people to be able to work fast on small things. Failing fast, for all it's been ridiculed, is a great concept for prototypes. The less investment that needs to happen to get something workable that shows it's a good idea. I think you can't argue that that's a valid way to go. So to be able to encourage small prototypes that show value is something that every team should be working on together. Once those are proved out as getting value, those should be promoted to real apps and features. What we want to avoid is rewriting these things, rewriting an R module into Java and then being told that they don't have the resources for that for the next year. We want to avoid IT debate club and budget debate club. So small prototypes are very hard to argue if you can get them done sort of as a slipstream as you're doing all the other things. It's very hard for people to combat that and say it's not a good way to use your time, because if things are getting done and you're proving out real prototypes, it's pretty much the ideal thing. And as you build them, as long as you're building to those standards where each stage communicates with the other in a common way, you don't have to fight about how much time we're going to have to do to rewrite this thing. And your prototypes can follow those same API patterns as your production software. Oh, and this little graph here is a cute, it's a cute Git flow diagram. But the concept here, it's a good way to think about it and talk about it inside your organization. What we do is our product, whatever it is, whether you're a services company or whether you're actually selling a product, that's your thing. Whether it's one recommender or whether it's a whole raft of customer behavior stuff, that's the thing that you guys are always putting out. That's what you're maintaining. That's what you're keeping alive. If you want to start a new thing, you can start it over here. You want to make sure that when you do that merge, it's not going to throw a lot of conflicts. Not just code conflicts, but, well, this doesn't access the API the proper way. It's to have all the integration tests and everything. And then similarly, when you want to build new features, you can cut out from what you have, add to that, and bring it back in. So, and that's, the idea there is to enforce proper separation between each of those pieces as well as teams. So here's a simplified version of what every machine learning platform should be. You're probably already doing this to some degree. Again, you have input data on the left and you have output data on the right. So input data can be anything. Output data can be a database table. It could be something it could just be a liquid file. It goes on Azure. It could be an Excel spreadsheet. It could be a PDF. It could be a live dashboard. But these 6 moving parts basically break out into 1, 2, 3 are where the data science and machine learning are. 4 is the UI and UX for presenting your results. 5 is a common API layer. And 6 is packaging all this stuff up for deployment. The skill sets actually do break out pretty cleanly. So 1, 2, 3 give a pretty similar set of skills. 4 for the UI is basically web development. 5 and 6 is packaging and DevOps. So here's how this looks. That's a pretty nice, clean development, clean separation. This helps you hire the right team, and also helps you if you need to outsource a piece. You can say, we need a web development shop to build this in the next 3 months. We don't need to hire that. So this helps you be a little more flexible building new tools. Here's where the DevOps come in. And that's where your data science and machine learning are localized. So to encourage these things, some more things. One thing we will see a lot of is, everybody having their own notebook, running on their own laptop. And I have very strong opinions about notebooks. And my podcast co-host Bill also has a good talk called "Why I Don't Like Notebooks." You may have seen it. If you don't, I recommend it. And a lot of that was about reproducibility, about making sure that what you see is what you expect, and also being able to share work properly. So people will reach for the tools that they know and they're comfortable with, but if you provide them with a maybe slightly more difficult way to get to something that's convenient and familiar, they will do it. So you can, instead of letting all those notebooks happen on people's laptops, you can have a central notebook repo using Zeppelin or something like that. That way everybody has their work in the same place, everybody can share work. Same thing with helping people do plotting and charting and dashboarding. You can give them a quick way to do prototyping. Using models for like prediction IO. Make sure you have APIs for all stages. Make sure that you enforce things like code reviews. Make sure that you help foster a culture of mentoring and collaboration and learning, and be able to say, I don't know, it's a big deal. Unit integration tests, table states. If you don't have a definition of done for your team, it is worth doing for your own self to write down, what do I mean by that? Because you may find that you're just missing some stuff. You may have something where we always miss that documentation step. Or our native build doesn't have Java docs working still. Remember 2 releases ago, we wrote that, and it's fine. Someone just has to run it by hand. All those things should be in your definition of done, should be a checklist, and you can't go home until it's done. Here's another talk by Phil. I would recommend about reproducibility. He goes a lot deeper into what I'm saying here. I highly recommend this. The idea here is that your data scientists and research scientists don't want to do software engineering. Academics like to be able to go off. It's nothing against them. I like this too. They like to go off and do their thing. They love it. It's beautiful. It's awesome. It's perfect. It works. And when they bring their work into a software engineering team and they encounter hostility, they don't know why. And the software engineers don't understand why anybody would bring this broken, terrible code to them. So this is a way to sort of bring the good word to the people in a nice way. Because scientists like reproducibility, data scientists like reproducibility, software engineering teams like reproducibility. disabilities. We all have something to agree on. So those slides are actually very beautiful. I would recommend them. So that's my hope for everybody here, that in the future we have regressions at scale, and that we don't, that we don't have to get hung up on which laptop that code was on and why we didn't push that. One plug for getting involved in open source, some of us are already involved. There's a few simple ways to get started. Fix documentation problems as you start using a project. If you clone somebody's repo and you're installing it and there's a bug, or there's a bash environment variable not set properly, it's not in the documentation, submit a pull request. People appreciate it. Fix bugs. Add an entire module to Apache group like Nick here. Add features as you can, and make it an internal team effort. If you have the bandwidth, if you have the interest, you can definitely waste a lot of time trying to get people into open source. We don't care. But it's a very nice way to grow skills inside your team, adapt that project to what you're actually seeing in the market, and then give it back to the community, which we all know is good. So thank you very much.
Have any names in real life horror stories you want to share? How it's nice.
I have, well, yeah, I mean, the one more story I talked about where we didn't move that wasn't me, but the metadata was not moved over to HDFS. That actually turned into another contract to fix that problem. No, I can talk to you about it in private. Awesome. Well, thanks everybody.